Okay, welcome to Geometry Unit 1, Lesson 2. We're going to talk about angle pairs today. So in your Unit 1 notes packet, this is Mr. Zacek. I have gone, and you're going to see I've kind of typed in some of these definitions. And so I'll talk about them, and then I'm going to draw some pictures as well as we're going through this. But let's get right to it here. So when we talk about angle pairs, obviously we're thinking about pair being more than one angle. So we can expect that today. So the first angle pair that we're going to talk about today is adjacent angles. And as we see here, adjacent angles they have a common vertex, they have a common ray, and then they have no common interior points. So let me draw a diagram here of what I mean by that. So if we have adjacent angles, we have, well, here would be one angle, and now we would have this angle right here. So these would be the adjacent angles. Now let's talk about what are those points when we're referring to where is the kind of common ray. So the common vertex is going to be this point right here. That's the vertex. The vertex is the point where these two rays meet. And then the common ray, obviously, that would be this line right here. So they're next to each other. When you use that word adjacent, it means next to. But they have no common interior points, meaning they don't overlap. So if we were to take a highlighter, okay, this would be the interior, all these points between these two rays, and this down here would be the interior of this angle. And what you notice is none of those are in common between the two, and that's what makes up adjacent angles. All right, the next pair that we have is vertical angles. And when we have, I don't want that line, when we have two lines that intersect, the angles whose sides are opposite rays, those form what we call vertical angles. Whoops, sorry. I want my pen. Let me just clean that up a little bit. Okay. Sounds like you can hear my daughter in the background. Okay, so we have, here is an angle, here's our two lines, okay, and the sides whose angles are opposite rays. So I'm going to call this one over here angle 1, and then I'm going to call this angle 2. And those are what we would refer to as vertical angles. So angle 1 and angle 2 are vertical angles, and they're always going to be equal or congruent to each other. And then this one up here is angle 3 and angle 4. So this is kind of, vertical angles are, they show up a whole lot throughout the course of this year. Excuse me. I like to sing this little ditty. If two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. That doesn't sound very rhythmical, but the idea that when two lines intersect, they form congruent vertical angles. So angle 1 and angle 2 would be vertical, angle 3 and angle 4 would be vertical. Okay, now, when we have complementary angles, complementary and supplementary, you're going to see, are very similar. So the definition of complementary angles is two angles whose measures sum to 90. Sum means add. So they add up to be 90. Each angle is called a complement of the other. So when you're looking at complementary angles, one of the little tips that people use to help you remember that is the CO forms the 90. So that's where we can get the 90 from in our complementary angles. So two angles whose sum is 90, and each one is called the complement. So if we were to give some values over here on this one, for example, if we have, that's my daughter Anna, she's very wonderful. If we have 50-degree angle, okay, then the complement of a 50-degree angle would be a 40-degree angle, because 50 plus 40 is 90. All right. And then the same idea of supplementary angles. So two angles whose measures sum to 180. Each angle is called a supplement of the other. So if we say 100, then the supplement of 100 would be 80 because they sum to be 180, and then the supplement of 80 would be 100, and you can see that. Okay, the next one is called a linear pair. And like the name suggests, linear, we think about when we have a line, and if we have some kind of angle, and pair meaning two angles that are happening here, so we have this going on, then these angles here, angle 1, we'll call this angle 1 and angle 2, those would form a linear pair. All right, so in a pair of adjacent angles whose non-common sides are opposite rays. So what does that mean? Well, there are the two adjacent angles and the non-common side. So this side here and this side, those are opposite rays. In other words, they're on a line. So there's a relationship with those, which some of you might see. If two angles form a linear pair, going to get better at this writing stuff, then they are supplementary. So whenever you see a line, you want to think those angles are going to be supplementary. These two, this whole thing here, that's like a semicircle or halfway around. You think if you're a snowboarder or a skateboarder, you do a 180. And so when we have those linear pairs that form a line, they form a 180. Okay, so definitely want to look over those vocabulary terms. And now we're going to talk about an angle bisector. So an angle bisector is a ray that divides an angle into two congruent angles. So the prefix bi means two, and sect means cut. So whenever we see that word bisect, we're cutting it into two parts. And what are we cutting into two parts? Well, we're cutting an angle. So here we see that ray BD bisects angle ABC. Now, when angles are named with letters, I was using some numbers earlier, but when we name an angle with a letter, we always use three capital letters. You'll recall from lesson 1 that the capital letters refer to points, and that the middle letter here is always going to be the vertex. Okay, so B is the vertex. That's what's being cut, and ray, BD, is cutting that. So what happens is it forms these two angles, and we can use this little marking here. That indicates that those two angles are equal. Sometimes you'll see a little slash there. That's a little notation here. So what happens to that is we would say that the measure, little m, of angle ABD equals the measure of angle CBD. And notice that in both of those, B is the middle letter. Okay. And when we have really kind of the two rays that are happening there, A, B, D, and the other one is CBD. Okay, so that is equal, and when we do equal, we're going to put that little M in front. That means measure, that's referring to the measure. But we also have another symbol over here, and this symbol is the congruent symbol. And it's an equal sign with a little kind of tilde above the top, and when we do the congruent, we don't need to write the measure. We can just write angle. All right, and those are interchangeable. If the measures are equal, they're congruent. If they're congruent, the measures are equal, and we'll kind of show when those different things apply. Okay, so that's an angle bisector. It divides an angle into two congruent angles. That's all these definitions are important, and it's important that we realize they're specific. Okay, so we're going to look at some examples here. Use the diagram at the right Is the statement true? Explain. All right, so here's where you want to have your highlighter, your colored pen out. This is going to help you to just get this clear. Okay, so we have here BFD and CFD. The question is, are they adjacent angles? Is that true? So see, let's look here. BFD and CFD, are they adjacent angles? Well, both of them, they have the common vertex. They do have a common side. They both have FC as a common side. However, they're kind of overlapping here, or they share common interior points. So this would be false. Okay, and the reason would be because they, I'm going to write overlap, or we could say they share common interior points. Okay. So therefore, that is not true. That's false, and that's why. In order for them to be that way, that would be the conditions. All right. I'm just going to erase that now because we're going to do a new question. I don't want to confuse myself. All right, for this question, our AFB, let's look at this now. So AFB, that's that one there, and EFD, okay, EFD, are they vertical angles? So angle AFB, that would be this angle right here, and EFD, that would be that angle. Is that true? And the answer to that is, that's false. Okay? And the reason is, my drawing mucked it up a little bit, so let me show you here, is that this angle is not the same line right here. So we have the line AFD going through and BFE. Those are not two intersecting lines, okay? So the reason is that it's false is they are not formed by two intersecting lines, okay? So they are not formed by two intersecting lines. All right. So our next question, are AFE and BFC complementary? So let's do this. Let's do our little reminder. Complementary is 90. So AFE, that's 62. And BFC, that's 28. That's this one here. Okay. That equals 90. So yes, that's true. Okay, the sum is 90. Now, D, our BFC, that's 28. That's the one that we just did. The measure is 28. And DFE, let's look at that one. DFE, that's 118 down here. So this one. Okay, plus 118. I don't remember if I did that, but the supplementary thing is if the complementary, the C makes the 90, the supplementary, the S makes the 180. That's the little thing. Okay, so when we add those two angle measures together, we get, what is that? 138 and 8, 146. Okay, that's not 180, so that would be false. Okay, and the reason would be because their sum, SUM, is not 180. All right, so hopefully that helps you get some of those examples here. Now let's look and see here what we've got going on with this. All right, I want to point out some notation that we have here. On this line, what we have, these little markings right here, these are called tick marks. And what it means is, it means that that segment is congruent to this segment down here. So what do we see? TW is congruent to VW. And can you make that conclusion? Yes. All right, and the reason we can make that conclusion is because of the tick marks. They tell us that. We're going to become very familiar with those throughout the course of this year. Now, PW and WQ, while those two segments look like they're the same, we don't really have any information that tells us that they are. So looks can be deceiving, and so we cannot make that conclusion. Can you make this conclusion? No, we can't make that conclusion. All right, and then TWQ is a right angle. Well, it certainly looks like a right angle. Right angles form 90 degrees and perpendicular lines, but we don't really have anything to prove that. So no, and we could say not enough info. Okay. Same for B. No, not enough info. All right. Just because it looks like it, that's not strong enough for us to make that conclusion. Okay, how about this? TV bisects PQ. So TV, now the order of this is important. So TV bisects PQ. What that's asking here is PQ being cut into two equal parts? And the answer is no, we don't know that. Okay, so we don't know. Whoops. We don't know. There's not enough info. All right, now, next part, PWT. So that's this angle here is angle PWT, and angle QWV, that would be this angle right here, are those vertical angles? And the answer to that is yes. Okay, why? Because if two lines intersect, then they form congruent. Well, we're going to leave out the congruent. We'll put that in later. They form vertical angles. If two lines intersect, then they form congruent vertical angles. Nobody's going to buy that song. All right. Yes. So that's what we're looking at. Two lines that intersect, congruent vertical angles. How about F? PWT, this angle up here, PWT, and PWV, this angle, are they adjacent angles? Well, look at that. Adjacent. What are the three things that we need? We need a common vertex. They have that. We need a common ray. And we have no overlap or no kind of shared spots. And so we would say yes. And the reason is common vertex followed by a common ray. Common means they both share it. And no overlap, or no common interior points is another way of saying that. Okay, now we're going to do a little bit of, this is going to start to get into a lot of what we'll do this year with the justify and explain piece. So we want to create a, justify means give a reason for why we have what we have here. So let me kind of lay this out for you. This is going to be really helpful for us to get a good grasp on as we go along. All right, so KLP, angle KPL, and angle JPL are a linear pair. Now that's given to us, okay? So that information, linear pair, And when we hear that word linear pair, we want to think they're supplementary. They add up to 180. So the measure of KPL is 2x plus 24. We see that in the diagram. And the measure of angle JPL is 4x plus 36. We also see that. What are the measures of those two angles? Justify and explain. Now here's the part, we're going to kind of revisit like some algebraic proofs that we did earlier in the year. So just kind of, bear with me as we do this and we'll get our feet into this. Okay, so here's what I want to start off with. I want to start off with the measure of angle KPL plus the measure of angle JPL. Give yourself some room. We're going to have to write a bunch of stuff. Equals 180. And the reason for that is they are a linear pair. Okay? Now, we know that KPL is represented by this expression 2x plus 24. And JPL, the measure of JPL, is represented by 4x plus 36. That equals 180. So what did we just do? We used substitution. Okay. Property, postulate, depending on the textbook, those are different. Okay, so now what are we going to do? Well, we've got some algebra here, and we're going to, look at this, we got like terms here, like terms here. We're going to combine those. So we'll get 6x plus 24 and 36 is going to be 60. And that equals 180. All right, so that step, what do? We just simplify. Okay, sometimes I'll write that as CLT, combine like terms. Well, we know that the next step would be to subtract 60 from both sides. Okay, and we would be left with 6x equals 120. Well, what's that? If we remember from algebra, that is the subtraction property of equality. All that the equality part is it means you're just doing the same thing to both sides of the equal sign. And we subtracted. Now what are we going to do? Well, we're going to divide. So we would be left with x equals 20. And what reason is that? That's the division property of equality. So what I'm kind of outlining here is a little bit of the algebraic proofs that we did last year. That's kind of our justification or our explanation. Okay, so now our final step here is we wanted to figure out what are the measures of those angles. So the measure of angle, whoops, that looks bad, KPL is 2x plus 24, and the measure of angle JPL is 4x plus 36. And what are we going to do? Well, we're going to take that x and we're going to put it in. We know x is 20. So the measure of angle KPL is going to equal, we can simplify that, it'd be 40 plus 24, which would be 64. And that's the measure of angle KPL. And over here we have the measure of angle JPL, and that's 4 times 20 plus 36. Measure of angle JPL equals 80 plus 36, which is 116. All right, so we have those. So that's a little bit of what we would call a proof, or giving some justification or explanation for how we approached that. All right, now we have one more of these, and again we see this big word here, justify and explain. Okay, so let's look at what we're given. AC bisects angle DAB. Well, that means cut in two, and you can actually see that kind of from these angle tick marks. This one and this one, those angles have been cut into two equal parts. If the measure of angle DAC equals 58, what is the measure of angle DAB? Okay, well, let's just think about this and then we'll kind of write it out. Well, if we know that this is 58, we know that this angle here is going to also be 58. Now, what we're looking at here is we need to find the measure of angle DAB. So what is angle DAB? Well, that's that whole big angle right there. So if we took those and we added those two together, 58 and 58, what would we be left with? Well, we would be left with 116 degrees. Okay, now we know how to do that. Let's go about kind of justifying that and explaining that. So here's how this would look. AC bisects angle DAB, and the measure of angle DAC equals 58. That is given information to us. Okay, we know that, so it's given. We might number these. We might say, okay, that's a statement, and there's a reason for it. And then we might say, okay, well, now what do we know? That since it bisects it, we know that the measure of angle DAC equals the measure of angle BAC. Those are the two parts that, because it's bisected. So, well, what is that? That right there is the definition of an angle bisector. Definition of an angle bisector. See, we just, we talked about that definition, now we're using it. Okay, well, what can we do? Well, if the measure of angle DAC equals the measure of angle BAC, then 58 equals the measure of angle BAC. So that right there is what we would just call substitution. Okay, now how do we get to the other one? Well, the measure of angle, the big one, DAB, equals the measure of angle DAC plus the measure of angle BAC. That right there is called the angle addition postulate. We'll go into more detail on that. Not today, but in a lesson to come. All right, and then what are we going to do? Well, we're going to substitute those in. Measure of angle DAB equals 58 plus 58. What did we do there? We just substituted. So substitution. Okay, and then we're just going to simplify that on our last step. So the measure of angle DAB equals 1/16. All right, so and that was just simplify. So what we need to kind of get used to doing, especially big emphasis in geometry, is we've got this kind of part over here that we're done. We know that kind of intuitively, but now we've got to get ourselves used to how do we kind of write this out, all right, in this format. Okay, so the reflection piece will be up in our Buzz Learning there, and we'll work with that. So great job there on lesson 2.